Today's video is about buoyancy and gravity, and this is just like a good foundational knowledge for understanding flat Earth and a biblical Earth, biblical cosmology, and breaking free from that spaceball paradigm, because gravity is like their golden ticket to get out of anything. Have you noticed that? All sorts of things can get blamed on gravity, and yet they'll readily admit, oh, we don't really know what gravity is, which is just a lie, because I think a lot of them know gravity and buoyancy are the same thing. I think a lot of them actually know that. But they can say at the same note, oh, we don't really know what gravity, nobody actually knows what gravity is. I think it's kind of a way to joke about how it's not real. Gravity's not real in that it's a made up concept for something we already had a name for. We already had a name and an understanding for buoyancy. Newton's third law tells us that every action has an equal opposite reaction. Every force has an opposite force to match it and balance it out. So they took a real force, buoyancy, looked at the opposite force created by buoyancy and gave that a fancy name, and then started making up all this fake stories about how it comes about. And so that's basically the idea of gravity. It's just a made up concept to explain something that already had an explanation and didn't need. Well, there's still the mystery of, well, why does buoyancy come about? And that'll be your best answer. In my opinion, the sciencey minded, most people who are like, oh, science is cool, if you ask them, like, what is the equal and opposite force to gravity, I don't think that they'd have any clue what you're talking about. And if you said that, well, buoyancy is the real force and gravity is just a name, a different name for the same thing, something that already exists, a lot of them don't even have the capacity to understand that. But the best answer that you'll get out there, you know, if you're going to make good arguments, you want to know what's your opponent's best argument. Their best argument is going to be, well, gravity or buoyancy wouldn't exist without gravity. Buoyancy needs gravity to exist, is what they would say. And then you just have to follow up with, well, wait a minute here. Gravity is this unproven theory about the reason that we experience a buoyant force, feel going down. You're telling me that the reason that I feel a force to go down, it's not just because I'm suspended in air and I'm more dense than air, so therefore I go down. That's the real truth. That's the one that I've always understood. When somebody first explained gravity to me, I knew it was stupid. I was like, what are you talking about? If an apple is on a tree and it stops being held up by the tree, the apple is more dense than air. It's going to go down. What? There's nothing to be explained there. That's just understanding buoyancy and how buoyancy works. And you don't need gravity for any of that. So anyways, the best answer out there, people will say, well, buoyancy doesn't exist without gravity. Well, you'd have to prove that. And then they'll say, well, G, look at the formula for buoyancy, and there's going to be a G in there. You still haven't proved causation at all. All that you've proven is that God created creation, and there are physical constants to this place. I'm not saying that there doesn't exist a physical constant, G, that describes how objects fall. Nobody says that. But here's the problem, though, is it takes kind of you need a big understanding or a decent-sized understanding to even comprehend what's going on at this level, where people, because, you know, that's going to be a gotcha, aha moment for a lot of people. Well, look, there's a G in buoyancy. Just because there's a constant G, a human gave it the letter G. It's not like, okay, there exists a physical constant out there that helps us describe free fall objects. Yeah, that doesn't prove that the mass of Earth is so massive that it's bending space-time. Anyways, you get the idea. So, I guess really quickly, I'll just go into all the science is awesome nerds. They always have the same bad arguments. One of them is, well, which way, why does buoyancy only go up? Like, why not to the right or to the left or diagonal? Why just up? But then, which is funny that they're like that when their whole reality is like, there is no up. Like, why do they think that that's a better answer? They think that they're slick. Well, why doesn't an apple fall to the left? Well, because that's the way that God made this place. That's the way that it's been since the beginning. Genesis chapter 1. In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. So there was just water, a flat water world is, in my opinion, what it was like in the beginning. In the very beginning. At least that's what Genesis 1 makes it appear to be so. Where's all the water and NASA stuff? I don't understand how 501c3 people interpret Genesis to make any sense with Ball Earth stuff. It's not compatible. Okay, so there was water in the beginning, and we know the we know the Earth system to be this like bubble protected inside of a firmament with waters above and waters below. That's the whole idea behind the Israel flag, by the way. You got the blue underneath, the blue stripe, and the blue stripe above. Waters below, and the waters above the firmament. Anyways, there was flat water. The point being, if there already was water in the beginning, flat water world, God had already oriented at that point up and down. Up and down was established in the beginning. God established it, and it has not changed. So that answers the question, why doesn't an apple fly to the left? Because God did not make this place to be like that. God built the universe and built everything, the whole physical realm. And so he, just like a computer game, you get to program it with how it's going to work. God made this place a certain way with certain physical rules. It's not mass bending space-time nonsense. Well, I mean, that's basically it. I've said some stuff. What are the other things where people come out of the woodwork to try to... That's the big one. I hit some of the big ones. People say buoyancy can't exist without gravity. It's like a chicken and the egg situation. If they're both describing the same force, it's two sides of the same coin. To say that one of those created the other one, I think that's going to be a hard argument. And anyways, we'll get to a slide later that gives me something to say about that. Normal, they try to disguise gravity with the normal force, but that's just buoyancy. When you're not dealing with water, this is kind of an interesting thing too, is that we tend to forget that we're basically submerged in a liquid, or there's a term for it. There's like a science term, not a liquid, but a fluid. Yeah, okay, fluid. Air is a fluid in the same way that water is a fluid. When we have water and we start having things floating or sinking or being suspended in a column of water, okay, our mind goes there to buoyancy. But in our everyday interactions, it's not very often that we deal with things that are lighter than air, or even things that are the same as air. I mean, springtime, you see stuff flying through the sky, so maybe a little bit. But you get my point. When you're facing water, the sink versus float is a lot more apparent, but that's going on with just regular air as well. It's still buoyancy, it's still sink versus float, but they get us able to not think about buoyancy when it's in an air above ground situation, and then they just only talk about gravity. Okay, so if you read through this thing, they do actually mention buoyancy in fluids, and hey, air is a fluid, but like I said, if it's like a free fall problem, they don't frame it as buoyancy. They say normal force. I think, in a way to obscure the fact that, oh wait, gravity is always opposite a buoyant force. But because they're going to talk about, okay, I remember now. This is the other boneheaded, one of the very often repeated things about gravity is, one, why doesn't the apple go sideways? Well, I explained it. In the beginning, God had already established up versus down. Down has been established. Sideways is not down, so things don't go sideways, they go down. Second one is, well, why does something fall in a vacuum? If gravity is not real, why does something fall in a vacuum? Since when is an object not more dense than a vacuum? If an object is more dense than air and it falls down, it's still going to be more dense than a vacuum, and it will still go down. Removing the air doesn't stop there from being a more dense goes down situation. So anyways, got those out of the way. A force opposing gravity. Every action has an equal opposite reaction. Does gravity have an equal opposing force? From asking around, I still haven't got a very clear answer. Well, here you go, buddy. It's buoyancy. And buoyancy is the real force. And it's just a way that God made this place. Gravity is just a fancy name that they've given to the opposite direction. The equal and opposing force to gravity is gravity. This is just wrong. The earth pulls on you and you pull on the earth. Well, okay, bozo. Equal, and it's an equal and opposite force. So are you telling me that the force that the earth is pulling on me is allegedly equal to the force that I pull on the earth? You make no sense. They don't even know their own things half the time. I've gone over enough. A big problem with finding it's interesting though that they're very withholding from this information. You don't hear about this stuff unless you're doing fringe science. It's so insanely weak. This is one of the big lies about gravity. Oh, it's so weak. There's the reasons you can't understand these things. Well, it's actually super weak. Oh, well, it's actually the main thing shaping they're bullshitting you. So here was actually an interesting thing. There's the centripetal force, which is the real force, allegedly, but the centrifugal force. So when you're in a machine or something that's spinning around and you feel yourself flying away. First of all, that's a big thing. And you hear this out of like science professors when you talk about how we don't feel the earth move, and you would definitely be able to feel the earth move. Immediately, they give a really bad analogy. They say, well, if you're in a car and a car is moving, you don't feel it moving. Spinning and going in a line are different things. Even if your rotation is constant, you still feel that force trying to throw you off of it. And that is the centrifugal force. But what's interesting is that force that you feel being pulled off of the spinning object, that's not even the real force. The real force is the table keeping you on the object, and what you're feeling is the equal opposite force. So that's just interesting about gravity, because what we feel with gravity is being pulled down, but the real force is buoyancy, is the fact that we're suspended in air that's, I don't know, trying to go above us. I don't know how to really get a good grasp of understanding buoyancy. It's kind of an interesting, it's an ordering that God gave this place. God declared that more dense things will go down. Yeah, where does it say? Centripetal force is the real inward pointing force. I just thought that was really interesting, how in this real life scenario, we all know what it feels like to be on a merry-go-round spinning around. That force that we feel that pushes us off the thing, that's the inferred equal opposite force. The real force is the fact that you're being held on to something. The table or the carousel that's holding you on is applying the force, holding you on there, and you're feeling the equal opposite force. So that's just interesting that in the same way, it's like we feel gravity pulling us down, but the true force is the opposite force of buoyancy. Here, sometimes they'll admit, I think I kind of got, I mentioned this a little bit earlier, where when we're dealing with water stuff, okay, buoyancy gets talked about. When you're dealing with like balloons, buoyancy gets talked about, but it's peeps when we're just dealing with the everyday objects falling through air. People stop talking about buoyancy, even though it's the same thing. The fact that objects fall through air is the same reason a rock falls through water, and it's the same force, and nothing's changing about that. Here you see gravity. It's that equal and opposite force pointing down, opposed to buoyancy. So here, just the last thought experiment that you need to think of, and it really is a good thought experiment, the whole idea of hot air balloons. Suppose that gravity is a real force, okay? So you have a balloon laying on the ground, sitting there, and imagine that you believe gravity is a real force. So you think that the Earth is pulling on the basket, or you think that the Earth has created a dip, a trench in the space-time continuum that's sucking the balloon towards it. However you want to think of it. If you really believe that that's like a force, well, how come the very instant the balloon becomes more buoyant than air, it starts going up? There's no force to overcome. It's not like you have to make the balloon buoyant and then inflate it even more to overcome the weight of the basket. That's just not how lighter than air travel works. What you realize is that there is no gravity to overcome. And the second you make something buoyant with air, you're no longer being pulled down. Well, you never were being pulled down. You simply were more dense than air. And God has ordered his creation with buoyancy, where the more dense goes down. Is that enough rambling for you guys about balloons and buoyancy? Yeah, so this goes, I just made a video a couple days ago about NASA. It's NASA's fault that it's $2 to fill up a simple balloon these days. And it's because the rockets, when NASA shoots off rockets, that's more of a spectacle than anything. They use balloons. They use the helium. The reason that NASA uses so much helium is because all of the satellites, they just use balloons. It's just weather balloons. And I actually kind of mentioned this a little bit, where recently I was kind of shocked at the small number of alleged satellites they say they have up there. And I was like, well, it makes sense that they would have to not say an outrageous number, because they're not launching rockets constantly. It's not like we're having rocket launches all the time. But what they are launching all the time are quote-unquote weather balloons and weather satellites, and that's why NASA needs so much helium. They really send a lot of balloons, and that, maybe I could look that up. They send a lot of weather balloons out, and that they'll readily admit to it. And what do you know? Like, that's the perfect, we get this satellite imagery, satellite whatever, they even admit low Earth orbit, because it's all underneath the firmament, and most of this stuff is just weather balloons. Well, that's it for this video. God bless everyone.